Bismillahirrahmanirrahim. Exercise 7.4, question number 1. Compute A cross B and B cross A. Check that each A and B is perpendicular to A cross B and B cross A. The given vectors A and B are vector A equals to 3i minus 2j plus k, vector B equals to I plus j. We start the solution. First of all, vector A equals to 3i minus 2j plus k. Vector B equals to I plus j. As k is missing, it means the coefficient of k is 0. So I have written the vector again with unit vector k like that. I plus j plus 0 into k. Now A cross B is simply equal to the determinant of first row is I, j, k. In the second row, we write the coefficients of vector A, that is 3, minus 2 and 1. You can see 3, minus 2 and 1. And in the third row, we write the coefficients of vector B, that is 1, 1 and 0. You can see 1, 1 and 0. Now evaluate this determinant. We expand the determinant from the first row, I into 0 minus 1 minus j into 3 into 0, that is 0, minus 1 into 1, that is 1, plus unit vector k, and we are going to write it with this as 3 into 1 minus 1 into minus 2 becomes plus 2. You all are familiar with the expansion of determinant from the first row. So this is just the expansion of determinant from the first row. Now perform simplification. I into minus 1 becomes minus I, minus j into minus 1 becomes plus j, and k into 5 becomes 5k. So this is A cross B. Now consider A dot A cross B. Dot product of A with A cross B, and write the vector A, write the vector A cross B. Vector A is 3i minus 2j plus k. A cross B is minus I plus j plus 5k. Perform the dot product, and for that, coefficient of I into coefficient of I, that is 3 into minus 1. Here it is. Plus coefficient of j into coefficient of j, that is minus 2 into 1. Here it is. Then coefficient of k into coefficient of k, 1 into 5. Here it is. Result, minus 3 minus 2 plus 5. So minus 5 plus 5 equals to 0. As the dot product of these two is 0, result, this vector is perpendicular to this. So we have checked that A is perpendicular to A cross B. Now consider B dot A cross B. The vector B is here, the vector A cross B is here. Perform the dot product. Coefficient of I into coefficient of I, 1 into minus 1, minus 1. Coefficient of j into coefficient of j, 1 into 1 is 1. Coefficient of k into coefficient of k, 0 into 5 is here. Result, minus 1 plus 1 plus 0. The answer becomes 0. As dot product of these two is 0, so these two vectors, this vector and this vector, these two vectors are perpendicular to each other. Let's get to the second part, that is we have to evaluate B cross A. Here it is. The vector A is this, the vector B is this. To evaluate vector B cross A, we take the determinant. The first row is I, j, k. In the second row, write the coefficients of the vector B. In the third row, write the coefficients of vector A. You can see 1, 1 and 0. The second row is 1, 1 and 0. And in the third row, you will write the coefficients of vector A, that is 3 minus 2 and 1, which is 3 minus 2 and 1. And now expand this determinant by the first row. With I, you will get 1 minus 0. With minus j, we will get 1, 0 into 3, that is minus 0, 1, minus 3 into 0, that is 0. With unit vector k, you will have minus 2 into minus 3. So here it is, I into 1 minus 0, minus j into 1 minus 0, plus k into minus 2 minus 3. Result becomes I minus j minus 5k. So this is B cross A. Now consider A dot B cross A. This is the vector A, this is the vector B cross A. Take the dot product, 3 into 1 plus minus 2 into minus 1 plus 1 into minus 5. Result 3 plus 2 minus 5. Answer is 0. Hence, vector A is perpendicular to B cross A. Now consider B dot B cross A. The vector B cross A. Take the dot product. Coefficient of I is 1. Coefficient of I is 1. So 1 into 1 plus 1 into minus 1 plus 0 into minus 5. Result 1 minus 1 plus 0 equals to 0. As the dot product is 0, so we must have that this vector is perpendicular to this vector and the solution or the proof is complete.